Welcome to the Deep Dive. Today, we're tackling a topic that's shaking the very future of AI. The difference between AI agents and something the research world is starting to call Agentic AI.
That's right. For a while now, AI has been great at single tasks or, just responding to prompts. But what we're seeing now are systems that act with more independence, pursue goals, and even work together.
Exactly. And these terms, AI agents and Agentic AI, they're flying around. Are they the same thing? Is one just like a fancier version of the other? And critically, why should you care about this distinction?
Well, we're diving into some recent thinking that lays out a pretty clear way to understand these two concepts. We're looking at what they are, what they can do, and importantly, where they fall short.
Okay.
Think of this as your essential guide to the next wave of artificial intelligence.
Okay, let's unpack this then. Our mission here is to get clear on these distinctions, sort of build a shared vocabulary, and explore the capabilities and challenges, all based on this latest research.
That's good.
So let's start at the beginning. What exactly is an AI agent?
Okay. Based on the thinking we're exploring, an AI agent is essentially an autonomous software program designed to perform specific tasks.
Right.
There, where AI moves from being just a model to something that actually does things in the real or digital world, interacting with users or other systems.
Got it. So more than just answering questions, they act.
Yeah.
Like a bot, maybe, but with a defined job.
Precisely. Yeah, they're different from a general purpose model you might just chat with. An AI agent is set up with a specific purpose, it has a limited scope of operation, and it's built to persistently work towards that task. So while a standard language model just waits for your next instruction, an AI agent is actively engaging with its environment based on its programming.
And the research highlights some core characteristics that really define what makes an agent.
Yeah.
An agent, right?
Yes, it points to three foundational traits: autonomy, task specificity, and reactivity.
Autonomy, okay, that means once you deploy it, it can operate on its own with like minimal human handholding, which is key for handling things at scale.
Correct. Yeah, they can make decisions and take actions independently, but, within their defined parameters.
Task specificity.
Yeah.
So they're built for narrow, dedicated jobs,
Yeah,
like, say, sorting your email or finding the best time for a meeting.
exactly. They excel at doing one or maybe a few related things repeatedly and efficiently within a specific area. They aren't trying to be like a general genius.
Right, not generalists.
No.
And reactivity that's responding to changes happening around them, like you giving a new command or a system sending back information.
Yes, exactly. They perceive their environment and react accordingly, and some can even adapt a bit over time, maybe refining their behavior based on feedback or remembering past interactions.
Okay, so autonomy, task specificity, and reactivity. Those are the pillars for an AI agent. Now, they rely on some pretty powerful engines, don't they?
Yeah.
Foundational models.
Absolutely. Large language models, LLMs like GPT-4, they're often the brain, right? Handling the understanding of language, planning steps, generating actions or responses.
Okay.
And for tasks involving sight, you have large image models, LIMS, which extend this capability into the visual world, allowing agents to perceive images or video.
So an AI agent uses these models to understand what's going on and then decide what to do. The research gives a great visual example here. Imagine a drone inspecting an orchard.
Ah, yes, the drone. That's a perfect example of an AI agent. It uses a limb to see and identify problems like diseased fruit or damaged branches from the air.
Right.
Then, autonomously, based on what it sees, it triggers a specific action, maybe sending an alert to the ground crew about the precise location needing attention.
So it shows both a perception, using a model, and then taking an independent action focused on a specific task.
Exactly. Perception and autonomous action.
That really locks in the idea of task specificity and autonomy. Now, generative AI came first, and it feels like these agents kind of build on that. How does generative AI fit into this picture?
Well, generative AI models, powered by LLMs and LIMS, they're incredible at creating content, text, images, code, you name it. But fundamentally, they are reactive.
Reactive.
Meaning they just wait for a prompt and then produce an output. They don't really have a memory of past interactions over a long period. They don't maintain an internal state or pursue a goal on their own without being explicitly told each step.
Okay, so generative AI is like the raw horsepower, the ability to generate understanding or content.
Yeah,
But AI agents add the driver and the destination, the autonomy and the task orientation.
that's a good way to put it.
And the research also emphasizes that these agents are often smarter because they can use tools.
Yes, tool augmentation. That's a huge deal. Language models alone have limits. They might hallucinate, their knowledge gets outdated. So, to overcome this, AI agents can integrate external capabilities, like accessing the internet, using a calculator, connecting to a database or an API.
Like how systems based on LLMs can use a web search tool if you ask an agent a question that requires current info.
Exactly. It recognizes it needs to search, it uses a search tool, processes the results, and then formulates the answer.
Okay.
The agent identifies a need, makes a specific tool call, integrates the information it gets back, and then uses its reasoning ability to synthesize the final output. Frameworks like React, that's reasoning and acting,
Yeah.
they formalize this loop of thinking, acting, thinking again.
And we see this with agents for market analysis needing real-time data or coding agents using tools to run code.
Precisely. Those are great examples.
So an AI agent is basically a purpose-built tool. It leverages powerful models, uses external capabilities, does a specific job, and has a degree of autonomy.
You've got it.
Okay, so that's the AI agent. Now, the research talks about the emergence of agentic AI, which builds on these foundations, but seems to be, well, a significant step beyond.
Yeah.
What's the core difference there?
Agentic AI really represents a shift towards systems where multiple AI agents collaborate and coordinate. They work together to achieve larger, more complex goals.
Oh, okay.
It's about distributing intelligence across different specialized units and orchestrating their combined efforts rather than just one agent doing one thing.
So it's not just one smart bot, it's a team of smart bots working together towards a shared objective.
That's the perfect way to think about it. The research uses a great analogy. Imagine a single smart thermostat in your house.
Okay.
That's like an AI agent. It has some autonomy, controls temperature, but it works largely in isolation.
And agentic AI in that analogy.
That's your entire smart home ecosystem. You have dedicated agents maybe for controlling temperature, lights, security, perhaps even ordering groceries.
Wow.
They are constantly communicating, sharing information maybe about the weather, your schedule, energy prices, and they coordinate their actions to optimize for comfort, security, and efficiency across the entire system.
That really makes the distinction clear. It's the leap from automating a single task to orchestrating a complex, adaptive system.
Exactly. It's about orchestration. And the research points out key architectural enhancements that make this multi-agent collaboration possible.
Like having an ensemble of specialized agents.
Yes, exactly. Instead of one monolithic system trying to do everything, you have multiple agents, each designed for a specific role. Maybe one is a research agent retrieving info, another summarizes it, a third plans tasks. Some systems even model these agents after real-world structures, like having agents that act like different departments in a company. MetaGPT is mentioned as an example there.
Interesting. And they need much more sophisticated reasoning and planning.
Definitely. To tackle complex problems, agentic AI systems use techniques to break down big goals into smaller, manageable subtasks. They can reason recursively, sort of exploring different paths, and dynamically adjust their plan based on how things are going or if the environment changes.
They also require more robust, persistent memory.
Right.
Not just remembering the last step, but maintaining context over a longer time.
Crucially, yes. They need sophisticated memory systems, ways to remember specific events, general facts, complex relationships to keep track of what's happened, maintain context across different tasks and sessions, and coordinate effectively over long periods.
So individuals might have local memory, but there's also shared memory.
Often, yes. Individual agents might have their own short-term memory, but they can also access a shared memory that the whole team uses for coordination.
And finally, there's often a kind of conductor for this AI orchestration layers or meta agents.
This is absolutely key. For a team of agents to work together seamlessly, there's usually an overarching layer or maybe a dedicated meta agent whose job it is to coordinate everyone.
Like a manager?
Kind of, yeah. It manages dependencies between tasks, assigns roles to specific agents, helps resolve conflicts if they arise, and generally ensures the overall system stays on track towards the complex goal. The chat dev example mentioned uses a virtual CEO meta agent.
Right, the project manager or the CEO for the AI team.
Exactly.
So agentic AI is about bringing together these specialized agents with advanced planning, shared memory, and sophisticated coordination to tackle bigger, more dynamic problems than a single agent ever could.
That sums it up well.
And we're already starting to see where these show up.
Yeah.
The research outlines various applications. For individual AI agents, where are they proving useful again?
Right. For AI agents, we see them in those specific areas like streamlining customer support by handling routine queries, acting as intelligent filters for
Yeah.
emails, sorting the important stuff,
Yeah,
providing personalized product recommendations online, or autonomously scheduling meetings by finding common availability. These are all specific, well-defined jobs.
right. Tasks that are clear-cut and benefit from automation with a degree of autonomy. Makes sense.
Exactly. Now, for agentic AI, because it involves collaboration on complex goals, the applications are, well, different. Think multi-agent systems assisting in complex research projects,
Okay.
or coordinating multiple robots in challenging environments, like that fascinating example of robots picking apples in an orchard, working together to identify, pick, and transport fruit.
Wow, that orchard example.
That's pretty cool, right?
Yeah.
We also see potential in collaborative medical decision support, maybe agents helping synthesize data in an ICU or in adaptive systems for things like cybersecurity incident response.
So multiple agents working together to detect, analyze, and respond to a threat in real time.
Exactly. Different agents tackling different parts of the problem, coordinating as they go.
These are definitely tasks that require multiple steps, drawing on different types of expertise from different agents and constant coordination and adaptation. That multi-robot harvest. You need agents for vision, planning routes, grasping, sorting.
Transporting, all talking to each other, adapting to, say, fruit ripeness or obstacles. Yeah.
It really highlights the potential for tackling problems that were previously just too complex for automation. However, there's always a however.
Ah, yes. As the research is quick to point out, both paradigms face significant challenges.
For individual AI agents, what are some of those hurdles? Let's recap.
Okay, for AI agents, challenges include things like a lack of true causal understanding. They might see a correlation but not really know why something happens.
Right, but why?
Yeah. They also inherit limitations from the underlying models, like making things up hallucinations or being overly sensitive to how you phrase a prompt. Their planning can be limited, and crucially, safety and reliability remain significant concerns, especially for deployment in critical areas.
And for agentic AI, do these challenges just get bigger, amplified?
Precisely, they can be significantly amplified. When multiple agents interact, causality issues become much, much harder to trace. You run into communication bottlenecks, coordination problems. It gets messy.
And emergent behavior.
Yes, managing emergent behavior, those unexpected outcomes that arise from all those complex interactions, becomes a major challenge. And then you have the significant hurdles of just scaling these things up, debugging them, building trust.
Explainability must be tough too.
Hugely. Understanding why the system did what it did, plus security vulnerabilities and all that interagent communication and establishing clear ethical governance frameworks, it's a lot.
It makes perfect sense. More moving parts, more interactions, more complexity. It creates more potential for things to go wrong or behave in unforeseen ways. And figuring out who or what is accountable, that gets much fuzzier.
Yeah, accountability is a big one. The research really emphasizes that these are still early days. There are fundamental challenges and significant research needed, especially around building standardized ways to structure these systems and getting a deeper handle on system-level causal understanding.
But the research also looks ahead, right? Pointing towards potential solutions and future directions.
It does. For individual AI agents, work is focused on integrating more sophisticated models that can actually understand cause and effect, enabling agents to continuously learn and improve from feedback and building in better mechanisms for trust and safety from the ground up.
And for the more complex agentic AI systems, what's the path forward there?
Here, the future involves things like formal verification, basically, rigorous mathematical testing to prove a system will behave as expected under certain conditions.
Okay, more rigor.
Exactly. Developing robust ethical guidelines and governance is absolutely essential before widespread deployment, and probably focusing on building tailored systems for specific domains rather than trying to create one-size-fits-all agentic AI, at least for now.
It sounds like there's still a massive amount of complex research and engineering needed to safely and effectively bring agentic AI into widespread use.
It absolutely is. There's no doubt about that. And the research introduces a really fascinating, almost provocative concept at the very end. It's called the absolute zero or AZR framework.
Absolute zero. AZR. What's that all about?
It's an idea that completely reimagines how AI systems could learn. So instead of relying on vast external data sets created by
Which
humans,
is how most AI learns now.
right, instead of that, agents would autonomously generate, validate, and solve their own tasks. They'd learn by doing and verifying the outcome internally, maybe through simulated environments or, say, executing code and seeing if it works.
Whoa, hang on. So they wouldn't just process what we feed them, they'd learn by experimenting and validating their own understanding from scratch, like setting their own homework and grading it.
Kind of, yeah, exactly. This self-evolving mechanism could potentially lead to truly autonomous intelligence, capable of self-directed learning and adaptation in dynamic environments.
That sounds revolutionary.
It could be. And not just for single agents, but imagine collaborative agentic AI systems where the whole team co-evolves its understanding and capabilities together based on these internal checks.
So we've taken quite the deep dive here. We've moved from the concept of a single task-specific AI agent to the much more complex collaborative world of agentic AI.
Understanding this distinction is, I think, fundamental as AI moves beyond being just a tool you prompt towards systems that have their own goals and interact with the world and with each other.
Yeah.
It's critical for understanding where the current technology is, where the real challenges lie, and the incredible potential for systems that can tackle problems previously considered, well, impossible for AI.
It's a field that is clearly evolving at lightning speed. It feels like we're just scratching the surface.
Indeed. We really are. And it leaves you with a powerful thought to ponder, doesn't it?
Which is?
If AI systems can move towards learning by interacting with the world and verifying their own understanding, rather than being solely dependent on the data we give them, what kinds of truly novel intelligence and capabilities might emerge that are currently, well, beyond our imagination?
That's where it gets really interesting. Something definitely to mull over. Thanks for joining us for this deep dive.
Our pleasure. Always fascinating.